Hello everyone, my name is Wesley and in this video I'm gonna help you with Uart communication between an ESP32 and a STM32. Before we start the project, let me briefly explain about Uart communication. The Universal Asynchronous Receive Transmit is a protocol when two devices can share data. At this project, we will explore the full duplex configuration. According to the image, the TX pin of device 1 transmits data and the RX received. Both devices must share the same ground. With this connection, both devices can send and receive data. As Uart is a asynchronous protocol, it doesn't need any clock to coordinate the operation. Alright, but how the bits travel through the wires? In this example, we will send 8 bits from one device to another. Before communication, the voltage at TX pin is held high. When the talk starts, the voltage level drops out and will change according to the byte we want to send. In this case, we send the 01011010. Low voltage is 0, high voltage is 1. At the end, there's a stop bit with a high signal. Perfect. We send the uppercase Z to other device with Uart. Alright, now we know the fundamentals of Uart. Let's connect our devices. As said before, we use the ESP32 and STM32 to the project. I am using a generic ESP32 and a nucleo H740Z2 board. The connection is easy. We use just 3 wires and connect it to PC. According to the image, the pin PC6 from STM goes to GPIO 16 and PC7 from STM goes to GPIO 17 from ESP32. Both share the same GND, the ground. Alright, now we set up the hardware, let's code. Here we have the Libre's Arduino.8 and driver Uart. Here in this 5 defines, we declare the standard Uart to use a serial monitor and the pines to RX and TX of RS32. The buff size will be used to allocate the data. At setup, we start the serial monitor with some tests and declare a struct to configure parameters for Uart, like baud rate, data byte, parity, and some other things. These 2 error checks are to set up the pins and allocate the data from the receive and sending data we are doing. In the ESP32 is always listening. We create a small buffer to store any incoming data here. And the Uart read bytes checks for new messages from the STM32. If data is found, we read it, print the confirmation to the serial monitor and free up the memory. Always free up their memory to protect your memory. Alright? In those parts, we are sending data to STM32. The program checks if you typed anything. If you have, it sends a simple H character to the STM32 using Uart to write bytes. Here at line 46. The continuous cycles makes the ESP32 a perfect listener and sender for our project. A tiny delay of 10 microseconds at the end keeps the system stable for the next loop. Alright, now at the ESTM32 we need 2 softwares, CubeIDE and CubeMX. At CubeMX we will configure our microcontroller. Here, this is the CubeMX. And to configure, we need to set up our connection. So we come here in connectivity And we'll use the Uart 6, the microcontroller we have here. Have other channels, but here I will use Uart 6. Here you will select the modes asynchronous, disable this option, and all the other things are standard. Alright? And a normal case, you will click on generate code, and the CubeMX will generate a basic code to you put your functions. I have everything okay here, so let's see the codes and CubeIDE. Here at the STM32 CubeIDE, we have the code to STM32. We will declare some libraries, some constants, and I will talk about some ones that are more important than others. All right. Here, the LED timeout is a constant that tells the program to turn the LEDs off after 200 milliseconds of no activity. At here, we have the RX byte, a temporary mailbox where the Uart places a single incoming byte. Last RX time is a timer. It stores the exact time the last byte was received, which we use to detect inactivity. TX data is a predefined message that the STM32 sends to the ESP32 when a button is pressed. In this case, we send hello ESP32. Those functions are standard functions from STM32 CubeMX, so we don't have care about that, just don't delete. Alright, enter in the main. We'll set some constants again, some pints, and here, how Uart receive it. This tells the Uart to listen for a single byte and trigger an interrupt as soon as it arrives. This is how the STM32 starts its continuous background listening. So STM32 is listened every time at the background. Alright? So in while our endless loop, we have two conditions. One is about LED and other is about the button. Alright, LED timeout. This block checks if the time since the last RX time is greater than our last timeout MS. If it is, it means no data has arrived recently, so the program turns on the LED. How it works? Our LED is always activated, and if STM32 receives something from the ESP32, he will blink the LED. Alright? And second, if we have button press. This part checks if the user button is pressed. If it is, the STM32 sends it to hello ESP32 message. A small hold delay of 100 milliseconds is included here to prevent multiple messages from a single button press. Think that's about something like a pull down resistor, alright? This entire process allows the STM32 to efficiently manage both receiving data from the ESP32 via interrupts and sending its own data on demand. Okay, so now we'll test these codes and show you how it works. Now we will test the system using the serial monitor with the ESP32 at VS Code. Okay, so I will start the ESP32. How you can see, we have those initial text, and now I will press the button at STM32 board. Okay, I press one time, receive it from STM32. Hello STM32. Perfect. So our STM are sending data to our ESP32. That's incredible. Now let's test the other way. ESP32 sending some data to STM32. I can press anything with my keyboard. What ESP32 do is read if something was right in the serial monitor and send the same letter, the letter H. Okay, so let's see. I'll text something here. He's sending to STM32H, received from STM32 STM, receiving byte H. Okay, now I will test this function again, and please watch the LED from STM32 board. Alright, as you can see, the LED blink every time I type something in serial monitor. So if you have any question about the project, just type your comments in the comment section, and thanks to watch this video. See you later.